What else do you remember? Just some keywords, whatever, to do with discharge tubes. So here's striations.
Gas.
Atmospheric pressure. Atmospheric pressure.
Vacuum.
Vacuum, so getting below atmospheric pressure. Cathode and anode, excellent. Can we identify the cathode and anode in this setup?
Cathode's at the top. Wait, what? No.
Have a look at the terminals on the power pack.
At the top, yeah.
So negative,
Cathode in the bottom.
positive. Yeah? Is that because that's the way it normally is, or because that's the way it's plugged in? Good. Alrighty, so this is a very large power supply. It can get up to 25 kilovolts, also known as ouch.
Ouch.
So I am going to be very careful with that. This is a glass tube inside a protective perspex tube. What do we expect to see in the glass tube when I turn the power on right now? What do you think you will see?
Nothing.
Nothing? Should we test it?
Yeah.
Nothing. Okay. How about we remove a little bit of gas? Yeah, go for it. And turn it on. What do you think will happen now? Striation patterns, that's our prediction.
Obviously pretty cool. Oh, it's blue. Oh, yeah.
You can see it on the camera.
Is it a striation pattern?
No.
Not yet.
What is it? It's yeah, can you see that it's kind of making like stripes all the way up the tube that's not very stable? What might we describe that as?
It's a stream.
Streamer. Excellent. So at the higher pressure you get a streamer. Let's close the valve and take it down just a little more and see what we get.
The whole tube.
What do we see now? What can we see? Can you see that there's a big pink column? What do we call that? No? Striation is actually a fancy word for striping. So what must this be? The something column. That sounds about right to me. You can see that there is a different colour up here. See the bright purple compared to the pink? What's happening is we are chucking electrons in at the top. They are accelerating down toward that anode, but we're generating ions in the gas as the electrons crash into the gas molecules. Those ions are coming back the other way and accelerating until they crash into some of the electrons up the top here. Makes a slightly different colour because there's slightly different energies involved. Let's reduce the pressure a bit more and see what we get. Now, do you see that the column is breaking up as the pressure drops? And now we've got quite clear stripes. I'm going to try and stabilise that. There we go. Can you see those bands? Right. So what's happening now is electrons accelerating out from the cathode there. They're speeding up through the field, but there's not very much gas here, so they're getting quite quick. The quicker they get, the more energy they have, the more likely it is for a collision to happen. But because the gas here is not very dense, the collision probability is fairly low, unlike before where the collision probability was high. You hit some sort of critical probability and you get lots of collisions, they start to slow down. They start accelerating again, you get a critical probability, lots of collisions, slows them down, etc., to make all these stripes. Make sense? Let's see what happens if I close this up some more. You can still see the glow from the ions coming back the other way. What do we call this gap here? Faraday's dark space. What about this gap here? Alrighty, and we're sort of gradually making that gap bigger and bigger and bigger because the less gas there is, the lower the probability of a collision, the further they're getting before you hit this critical probability of collisions. Fewer and fewer stripes until eventually, if the pump will do it and if the seals are good enough, the glow will disappear entirely. Once there's not enough gas, there's not enough to make a glow, you just get a dark tube, and you actually, if it's really, really dim, you can see the glass starting to glow greenish as the electrons hit the glass. Alright, should we do it in reverse?
Yes.
So, put a little bit of air in, and what do we call this one? This is the striation pattern. A little more in. This is column, and a bit more in.
You seen the video? Yeah.
And this one we call streamers. Cool. If you would like to pop the pump on, that would be great. And if you saw the smoke coming up the bottom of the pipe there, I was trying to avoid that. That pump works using oil, and it's just sucked some oil vapor back up because the pressure in the tube was suddenly lower than in the pipe to the pump. So that's all that was. That wasn't anything to do with discharge tubes particularly.